Okay. Tend to identify angles. So, as mentioned here, looking at what's going on here, you can see nothing but angles, drawing angles, angle measurements, whole bunch of angles, more angles. So, more angle stuff going on here. But we're going to introduce 5 vocab terms here. Get comfortable with these here. We will use them again in 10-5. When we start talking about triangles here, you'll realize these 3 terms, acute, right, and obtuse, happen to be right, acute, and obtuse, are 3 terms we're going to introduce today. So get comfortable with these terms here, what they mean, what do they look like, so on and so forth here. Bye, Haley. Have a good day. Thank you. Okay. You'll be missed by all. So thanks, Haley. Okay. So first off, acute angles. And this is classifying angles, where this will help, I think, for some of your angle constructions too, knowing kind of what different angles should look like there. But an acute angle is an angle that measures less than 90 degrees. All right. So I'm not going to use my protractor here. I'll just kind of briefly, that would be an example of an acute angle right there. Maybe a 40-degree angle. But when measuring, we measure this area right here. Again, Uriah mentioned it before about right angles here. Right angles are perfectly up and down. But if I just kind of briefly look at some of these things here, you should be able to realize probably 31, that's an acute angle, 33, acute angle, smaller angles. They're the smallest of the angles. A right angle. All right. Right angles measure exactly 90 degrees. Exactly 90 degrees here. Perfectly up and down the lines here. So I'll sketch a good one here real quick. Just so you can get a good, perfect look through what it looks like. Here's my 90 up here. Straight up and down it shall be. Right angles are very special angles. So there we go. You can see that it's perfectly up and down. This is a right angle here. But specifically, right angles have a specific symbol to them. So you're not, as we go through a lot of math stuff here, you don't generally use your protractor endlessly. It has its time and place here. But there's different ways to figure different angle measurements out here. Again, we'll get through this a little more this year and especially next year. But this symbol right here, it's like a square, so to say here. All right. This is the right angle symbol. When you see that box, that means it is a right angle, period, end discussion there. And the book also shows it there. But any right angle here will have this square box. So they say tell whether these angles are acute, right, obtuse, stuff like that. We'll talk about that there. But of these here, one of these I know for sure is a right angle. Which one of those is a right angle? 13, 14, 15, or 16? 15. Yeah, because again, notice the square right there here. That's not a square, that's not a square, that's not a square. They're different types of angles. But right angles always have that square there. Okay? They are perfectly 90-degree angles. So you will see that. I could pull out the bigger kid books here and go to angle sections there and stuff that we're doing there. But forever and ever in the rest of your math career, right angles are generally represented by this symbol. So that way you just know that that's a right angle. You know that's a 90-degree angle. So get familiar with what that symbol is and what it represents. An obtuse angle. All right, is an angle that measures between 90 degrees, so bigger than a right angle, and 180 degrees. So obtuse angles, if I just briefly kind of drew one out there, maybe something like that here, be an obtuse angle, because we know straight up and down, that's 90 degrees, that's a right angle. And if it's less than that, well, that's an acute angle. And if it's bigger than straight up and down, well, that's an obtuse angle. When I had you draw your two angles out here, your 23-degree angle should have been an acute angle. It should look similar somewhat to that there, where we know 90 degree is perfectly up and down, so we know the acute has to be smaller than that. It just has to be. And the obtuse, of course, has to be bigger, more wide open than that there. So when you're going through, some of you like drew for the 23, like Lauren, not singling out there, but you drew like a 160-degree angle. Yeah. But now you could probably understand, knowing what these different types, a 23-degree angle, it's got to be less than a 90-degree. And you know, as you're doing your compass or constructing your angles, if I say draw a 30-degree angle and you draw a 150-degree angle, you should be like, well, wait a second there. A 30-degree angle is going to be tiny, not this huge, giant, open thing here. 150-degree angle at the opposite angle, that would be a very big obtuse angle. So you could look at it and just be like, I don't think this is the right angle. I think I should use the other number on my protractor here to draw the angle. Last one is a straight angle. And straight angles measure exactly 180 degrees. Are you writing all this down, Michaela, in your notes? Because I doubt you'll remember all this. And straight angles are pretty easy to identify because they are literally just a line. I drew a line, but it's also an angle. It's a 180-degree angle is what I drew there. So straight angles are essentially just lines for all practical purposes there. And again, you can see if I tried to measure it there on my protractor, line everything up perfectly there, you can see 180 degrees. I have drawn a 180-degree angle. But straight angles are just straight lines. They are one and the same thing here. True. Okay. And then, again, don't need to write this down here, but then that leads to a reflex angle. A reflex angle is between 180 and 360 degrees. That would be like this angle measurement from here to here. Or this angle from here to here. The other way the angle could go.
Why wouldn't that just be obtuse?
Because obtuse are between 90 and 180 degrees. To find the measurement of a reflex angle, you would figure the measurement of this, say it's 40 degrees, and then the measurement of this angle, you would just subtract that from 360. 360 minus 40 means this would be a 320-degree angle. That way here?
So basically you can calculate like angle degrees up to 360, which...
True, but you can only measure these angles here. To find the reflex angle, you would measure this angle and then subtract from 360 to figure out the measurement of the reflex angle. So that's all I want to, again, we'll cover that concept in later years, but that's the fifth type of angle that's out there, the reflex angle. So, but that's all I'm going to say about that for now. So anyway, there's our four different angles here. And the main thing that we're going to be doing here is classifying the angles. Here's a whole bunch of them. Let's go through some of them here. I'll give you all a turn here. Knowing what you know about the four different types of angles. Number one, 34 degrees. What type of angle is that, Noah? That's an acute angle, right, between 0 and 90 degrees. Number 2, 110 degrees, Uriah. What type of angle is it?
Obtuse.
Obtuse, right. Number 4, 90 degrees, Lauren.
Number 4, 90 degrees, that is a right angle.
That's a right angle. Number 5, 180 degrees, Michaela.
Straight angle.
Straight angle, right. Number 13, again, they don't show you a measurement per se, but you should be able to kind of look at it and be like, I think I know what that is. Stella, what do you think 13 is?
Acute.
Yeah, it's acute. Yeah, it's clearly less than 90 degrees. 14's a little, Roland.
That looks, is that obtuse?
Yeah, I would say obtuse. So it's probably somewhere around 95 to 100 degrees, that angle. Certainly not a right angle, because number 15, George.
Right angle.
Right, that one, there's my square. The square always represents a right angle. And again, we see the square a couple other times. We'll talk about that here in just a second there. 16, Ella, what does that look like?
A straight angle.
Yeah, that's a straight angle right there. So, not real hard. It's just getting comfortable with those 4 terms and just trying to make sure you can remember which ones are which. Acute, right, obtuse, and straight. If you can remember them, that it's a lot easier to kind of remember what they are. Usually most people are pretty good about remembering the angles, so, but if this is the first time you're seeing these terms or whatever here, perhaps just consider looking at them once, twice over the coming days here. Maybe tomorrow in study hall, I'll quickly ask you which ones are which to help you remember, but you use these terms a lot. We'll use them again, as I said, in 10.5 when we classify triangles here, classifying triangles by their sides. This is an acute triangle, that's a right triangle, that's an obtuse triangle. How do I know? Well, we'll cover that when the moment comes, but those same 3 terms we'll use again here soon. And a bunch of different angles. A lot of angles going on here. You'll be naming angles, which means we need to write out our angles using the angle symbol. Make sure the vertex is the middle letter. So I'll walk through number 17 with you here. You can do it on your own there if you want, if you feel so inclined, but directions say, writing in our notes here, number 17. Where did I put my notes here? There they are on the sheet here. Name 4 acute angles. So feel free to give it a quick shot here, but I'll write this one out for you here. I see 1, 2, 3, 4. I see exactly 4 acute angles here. So we're going to do 17 through 20 in our notes. 17, 4 acute angles. All right, anybody think they see one? Uriah?
I see DFE.
Angle DFE, DFE, that is indeed an acute angle. So DFE or EFE. There's one. Anybody else? Noah?
CFD.
CFD, yes, I agree. That's an 80-degree angle. That's less than 90. That's an acute angle. George? CFA. Nope.
I said BFA.
DF.
I said B.
What?
B.
D?
B.
Oh, BFA?
Yeah.
Okay. Sorry, George. BFA. Yep, BFA. I see one more. Michaela?
C and F.
CF.
CFB.
CFB, right. So there they are. In no particular order. But good job to the four of you naming your angles, by the way. All of you were good. You got the vertex. It is F. That has to be in the middle there. That was real good. So on your own, see if you can answer the other three questions here. Two right angles. I'll help you with one of them here. There are two right angles there. Anybody have an idea what one of them would be? Noah? CAF is not an angle. CFA.
Oh,
Right. And how do you know?
because,
How do you know that's a right angle?
because it's straight up and down.
Besides using your eyes, that's not proof. It looks like a right angle. That's not good enough. Roland, how can I prove that CFA is a right angle?
Because, well, why isn't there, since it's a right angle, why isn't there the box?
There could be, but I can prove it another way. What do I know about the definition of a right angle?
Oh,
Else?
They all measure exactly 90 degrees.
Yes, but how do I know CFA is a 90-degree angle? Stella.
Yeah, because all the lines are straight up and down.
Again, you're just using your eyes. You got to prove it. Noah.
because 35 plus 55 is 90.
Yes. I can add these two angles together. Angle AFB and BFC make angle AFC. It's made up of two angles, essentially. But the sum of these two angles, a 35-degree angle plus that 55-degree angle, 35 plus 55 equals 90 degrees. And that's how I can prove it. The sum of these two angles totals 90 degrees. So this is an acute angle, that's an acute angle, but this guy right here is a right angle. Because if I add these two angles together, that totals 90 degrees. That's my proof. Instead of just using the eye test here. And again, you never want to rely on what you think or what it kind of looks like there. That's why we have these right angle symbols. And again, your question was fair, Roland. Could they have put the right angle box here? Yeah, they could have, but they generally don't when there's multiple angles that make a 90-degree angle, just because it would be a little confusing. Instead, you should go back to what you know, that a right angle is a 90-degree angle. The sum of these two angles forms a 90-degree angle. So if I said two right angles, 18, two right angles, and I would say angle either AFC or CFA, whatever you want there, they're both one and the same. Where's the other one? Ella?
CFE or EFC.
And how do you know?
80 plus 10 is 90.
Right, same deal, 80 plus 10. This 10-degree angle, this 80-degree angle form a 90-degree angle here. That's my proof. That's how I know definitively without just taking a stab in the dark. So again, yeah, you can see it, but what if there were lines this way and that way and all over the place here? Then sometimes it's not so easy to see, like in the higher levels there. So you'll need to fall back to add up the sum of these little different angles here and look for ones that add up to 90 degrees. So to say, to find that angle. The straight angle, where is it? Lauren?
F and C. What? No, AFE.
AFE is correct. How do you know?
Because it measures exactly 180.
How do you know? George?
Because everything together out there equals 180.
Right. Same general strategy that we use to prove the right angle. You can't just assume. 35 plus 55 plus 80 plus 10 totals, wait for it, 180 degrees. Just like we know 90 plus 90. A straight angle will always total 180 degrees. So again, being able to prove it more than just with your eyes here is what you're going to want to do. they're not going to be crazy figures here in 5th grade. Let's be realistic here. But the figures will get much more intense in future use here. It won't be so clear all the time to you where these angles are sometimes. So you'll have to be able to prove it a better way. And a better way is using math by adding up the sums of different angles there. Okay. What about the obtuse angles there? Anybody see one? Uriah?
I have all of them. But
Well,
I'll
you
just
can
give
give me
you
one of them here. So 19,
BFD.
straight angle, I'll write it down here for our notes, was angle AFE. Again, making sure F is always my vertex, making sure I'm using my angle symbol. Making sure I'm using my angle symbol. 23 obtuse. What was one of them, Uriah?
BFD.
DFB. What's the measurement of angle DFB?
The measurement of angle BFD is 135.
Right. It's a 135-degree angle. Go on, DFB is the one he found there. And he proved it by adding up these two angles that form. This is a 135-degree angle. Angle DFB. Where's another one? Stella?
AFD.
AFD. What's the measurement of angle AFD? 165 degrees. 80 plus 55. This is 90 plus 80. Or 90, or what did you say? DFA, AFD. 170 degrees. Right? 35 plus 55 plus 80. AFD. 170 degrees. Anybody else? One other? George?
EFE.
EFD?
B.
BFD? Or BFE?
E.
BFE. What's BFE's measurement?
145.
Right. And again, he got there by adding 55 plus 80 plus 10 to find a 145-degree angle in there. So, not bad. Not bad. Again, you'll get practice writing angles. You'll get practice using your angle symbol, making sure your vertex is in the middle, all that good stuff there. Here's where your protractor, again, you'll have to do this in your homework too. You've got 7 angles you need to measure in your homework, 9 and 15. So they want you to do 2 things here. Classify the angle, and what am I going to say? Like 30 through 33. So on your own, I don't want to do all of them. I know you guys want to move along here. But number 30, they want you to do 2 things. You'll have 7 of these types of questions in your homework. 1 through 8 is very similar to what we did here. You're just classifying the angle. You just give you a number, you tell me what type of angle it is. 9 through 15 in the homework is like this part right here. 2 things you got to do. Find the measure of the angle, classify the angle. When we say classify the angle, I'm saying, is it acute, right, obtuse, or straight? That's classifying the angle. But then measure. So you'll need your protractor. So again, if I kind of measure that one there, mine has these little lines, which I suppose help me, but this is a 140-degree angle here. Would you agree with that? And again, they build it the other way. This time, I still get my protractor right on the vertex. But this time, or I could turn it this way too, if I wanted. That's also, that way it looks like about 135. That way, what does the book say it is here? The book says it's 140 degrees. So that's not even on the thing there. There we go. Well, like such or so. There's my 140 right there. So you should be able to, again, if you're measuring and see at 40, because again, if you look, you can see if I go this way. Oh, okay. It's also 40 degrees. Well, if I look at it closer, you should be like, wait a second here. That does not look like a 40-degree angle to me, right? So you should probably use your other number then. Because if I build the line to the left and go up to the right, well, then I measure with the top line. But if I build my line to the right and measure to the left, well, then I use the bottom lines. Little confusing, I won't dispute that. But I'm hoping with your newfound knowledge about what an acute angle, what an obtuse angle looks like, that you could be like, this does not look like a 40-degree angle. So it's probably not a 40-degree angle. It's most likely the other one, 140-degree angle. Okay. So for this one here, number 30, I would write obtuse. That's me classifying, and then I would write 140 degrees. I would measure it. So try 31 on your own. I'll pull a stick out here. But classify the angle, measure the angle. If you don't have your protractor, then I guess hopefully you can classify it here. Measure it.
For 30?
31. Again, you may need a little piece of paper or something to help you make the angle longer and stuff like that. We talked about how you can do that. So, ditto in the homework. They can be, I assure you on your quiz, I write them nice and big for you. You won't have to fiddle around with a piece of paper or anything on the quiz. I write them nice and big for you. So it'll be real easy to measure. The book ones are kind of tiny. I get it, so. Alright, so what do you think? If you measure it, Noah, you don't have a protractor. Uriah, no protractor. Ella doesn't have a book. Okay, flying along here. Lauren,
It is an acute angle
it is acute.
with, I think it's 10.
I think 10 degrees?
10 degrees.
Wait,
170 acute angle.
George, what's its measure, do you think?
75.
Book says 70, but, you know, sure, why not? 75.
I was just trying to measure it out of the.
I got like 73.
So, yep, 73. So again, you probably need to turn your book on its side here to measure this one. And then, again, just kind of, again, there's so many lines on this thing here, but there it is, right on the 70 line right there. I could certainly measure it the other way too, and I'd have to turn my book this way. And again, you can see where the arrow is. It's kind of right on my 70-degree line right here. You see the arrow there, kind of. But 70 degrees is about where we're at here with that one. So yeah, they're small. Apologies. All right, last term we got to go through here. We're almost done. Is perpendicular lines. So perpendicular lines. And we won't get too deep into this stuff here, perpendicular parallel lines at the moment here, but a couple different things going on here. So perpendicular lines are intersecting lines. And when I say intersecting lines, I'm talking about two lines that cross each other. These are all intersecting lines. That is true. Are they all perpendicular lines? Well, that's a different conversation. But basically, intersecting lines are just two lines that cross each other, right? Most people understand what the word intersecting means, so. But perpendicular lines are intersecting lines, but more. They're more than that. That form 4 right angles. So, I'm not going to sketch it out perfectly, but it would look generally something like that, the book here. And how would I know that these are perpendicular? You will always see the right angle symbol around if the lines are perpendicular 100% of the time.
Even with the homework and stuff.
Well, the homework, they do it slightly different just because they want you to measure them off here. But the truth is, outside of this one lesson here, going forward, if you have perpendicular lines, this box will be here. And again, we don't know a ton of laws and theorems here about corresponding angles, opposite angles, vertical angles, not the point. So the way the book shows it is they show all four of these angles being right angles here. They are. And again, we don't need to mark all four of them, generally speaking, because there's theorems that prove they're all 90-degree angles. As long as you know one of them, then all four are. But whenever you see perpendicular lines, you will see this right angle box. Outside of today, they want you to use your protractor to prove it to you. But I'm telling you, pretty much forever going forward, if perpendicular lines are around, this symbol will also be in there. That's how you'll know that they're perpendicular. So that's how you'll know for sure. Last thing here. Again, we're getting there, but we started a little late, as we know. So, lines. And again, you'll have to write these things out here at times, but I'm just going to give these 4 points. So, there are 2 lines here. What's one of the 2 lines, if I gave it a name? George?
What's the middle one?
Stella, what's one of my 2 lines?
Line AB.
Line AB. What's the other one? CD. So, I know they're lines because, one, they go forever in both directions, right? You see that there? Forever, 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 forever. So, this time I'm using the line symbol. We talked about the raise symbol. But these are lines. These aren't rays here. These are lines. And then the last thing you need to know about this, and then we'll look at one here, is there is a symbol for perpendicular. And it's this symbol right here. It's kind of like an upside down T. When you see that symbol, that means that's the symbol for perpendicular lines. And you may see that symbol again this chapter or on a quiz or test. Not times, lines. Right there. It's basically this upside down T is what's going on. Michaela, you writing any of this down? You're just assuming you know it all already?
I was thinking.
Oh, okay. Well, you'll have that time in a moment here. But there's how the book shows the symbol there. They represent that line, RS. RS. Line is generally named by its endpoints, 2 points. Line RS is perpendicular to, there's my symbol, line PQ. So if this information is provided even without the right angle boxes, we know they're all right angles because this also is enough to prove perpendicular lines. It's the symbol for perpendicular lines. So a couple different ways you can know you're looking at perpendicular lines. Really, there's 3 of them. 1, you can find right angle box. 2, it can be specifically told to you using this symbol. Or what you'll do in your homework here is technically use your protractor. I'll tell you that 1 of these 4 are perpendicular lines. The other 3 are just a couple intersecting lines. 34, 35, 36, or 37. Which of those ones do you think make the perpendicular lines? George? 35? 35 is correct. So 37, it's kind of hard to tell, to be honest with you. You'd have to try and measure one of these 4 angles out here. But you know they have to be all 90-degree angles. So I don't know what the measurements of these angles are. I'm not going to frustrate ourselves right now with that. This one's kind of hard to see too. In your homework, they're a little trickier about it. All the lines are kind of sideways, so it's a little bit harder to figure out. But they want you to use your protractor. And again, the key is if you're using your protractor, all 4 angles, whatever one I measure, and they'll all be the same, will be 90 degrees. Does that make sense?
Yes.
Okay. Let's call it. All right. So,
Subscribe or Billy will eat
thank
you.
you. Thank